Welcome all. So, we are in the process of learning about the different concepts of the time value of money, and this is the last leg of discussion on this particular concept, time value of money. In this class I will close the discussion on this very interesting important concept of the overall financial management, because without time value of money, I told you many times in the previous classes also, we cannot take any kind of the investment decisions or any kind of the borrowing decisions, right. So, in the previous class we were talking about the equated monthly installment or EMI, how to calculate the EMI. This is one of the application of the your present value of the annuity. So, here all other information is given to us. You are given the borrowing amount, you are given the interest, but interest is per month here, and the repayment period is also given to us in the months. So, finally, you can make use of this particular model, and with the help of this model you can find out that how to calculate the EMI. Now, we will move to the next part, and the next part here is that is the present value of a growing annuity. Means the annuity which is we are going to have or we are going to say earn over a period of time, that amount which is going to come back to us over a period of time is not going to be the same amount, but it will be growing over a period of time. That will be affected by the growth rate also over a period of time. So, maybe it is the annual growth rate or maybe semi-annual growth rate or biannual growth rate, but the growth rate has to be there. Whatever is the cash flow is going to be there with us, that is not going to be the same cash flow, it is going to be the say cash flow with the grown up rate. Now, what is the say the growing annuity? First of all, because we are going to learn about the present value of a growing annuity. So, let us understand what is the growing annuity. A cash flow that grows at a constant rate for a specified period of time, is a growing annuity, right. A cash flow that grows at a constant rate for a specified period of time is the growing annuity. It does not remain same, it does not remain constant, it grows over a period of time. The timeline of a growing annuity is shown below. If you look at the timeline, we are more important to look for the timeline. The timeline of a growing annuity is given below to us, and if you look at the say normal annuity, timeline of the normal annuity, this is basically called as the ordinary annuity. So, it means because the cash flow is coming at the end of the year, so it is called as the ordinary annuity, and any annuity on which the cash flow comes say back to the investor in the beginning of the year, that is called as the annuity due. So, ordinary annuity, annuity due I will discuss with you in the say next slides, but here it is ordinary annuity, and if for example, if you are not multiplying A with the 1 plus G, 1 plus G is basically the growth rate. So, if you are multiplying A with the G, so it means it becomes a growing annuity. So, in the first year it is 1 plus G, in the second year it is 1 plus G power 2, then over the number of years it becomes 1 plus G power n, right. So, means we are getting this annuity, certain sum is assured, but that is also growing at a given rate of say growth, and that rate of growth is the constant rate of growth, right. The present value of a growing annuity can be determined using the following formula. Means finally, with the help of this formula we can calculate the present value of a growing annuity, and with the help of this model here what you are doing is, only change we have done here is that the earlier it was only A multiplied by the rest of the things, but now we are multiplying that annuity value also, A value also, that cash flow also, which is occurring at the end of the year is multiplied by the growth rate, and then in the inside this model you are say writing it here as a 1 plus G divided by 1 plus R power n, right, and here we are talking about is divided by the, earlier it was only R, but now it is R minus G. So, it means discount rate will also be adjusted against that the growth rate. So, it means a growing annuity when there is a growth in the annuity and the discount rate remains the same. So, it means your overall value, finally the discounted value of that annuity increases, that goes up, that increases. But here the point of caution is given to us. Let us read it what is given here. The above formula can be used when the growth rate is less than the discount rate. There are the two important things, R is the discount rate, G is the growth rate, right. So, this model is usable only in case R is say the growth rate is less than the discount rate, if the G is lesser than the R, or if the G is more than the R. When there is a difference in the G and R, G is something and the R is different, then this model is workable, this model is usable. But if the G and R are equal, if there is no difference in this, in case G is equal to R, if both are equal to, for example, in that case the model will not be applicable, and in this case what will be the say present value of that annuity? It will be NA. So, N means the total annuity which is coming to us, because the amount it is means the amount of the annuity which is reducing because of the discount factor, that is also being appreciated because of the growth factor, right. So, it means in that case R is equal to G, it means how much reduction is coming because of the time value of money, because that cash flow is occurring us 1 year from now. So, it means the value of that cash flow will not be equal to the same amount say coming to us or is available with us in the 0 period. So, that will be normally adjust, right. When you discount it, it comes down, future inflow, future annuity, when compared as per the today's value it comes down, but when it is supplemented by the growth rate. So, what is going to happen in future? For example, at the end of the 1 year we are going to get say your say 1 lakh rupees annuity, we are going to get 1 lakh rupees, which is growing at a constant rate of 10% over the years. But at the same time, if the growth rate if the discount rate is also 10%, then what will happen? The value of 1 lakh will be 1 lakh even after 1 year, which is we are going to earn after 1 year, it is going to be 1 lakh is equal to 1 lakh, even after 2 years that 1 lakh rupees is going to be there with us. The value of that 1 lakh rupees coming to us after 2 years will be equal to 1 lakh rupees of the today, because that discounted value, the reduction in the value is being made good by the growth rate. So, if the say R is equal to G or G is equal to R, then what will be there? The discount, they say the present value of the growing annuity will be simply the annuities, number of annuities means sum of the annuities. But if there is a difference, if the say G is lesser than R or G is more than R, in that case this model is applicable, and this model adjusts for that if there is any growth rate in the annuities and even that you discount it against certain discount rate, then finally the whatever the discounted value comes or is worked out more than the value of an annuity when it is not growing. When the value of annuity is constant and you discount it and then sum it up, something else will come up, some total value will different value will come up. But when in this case if you say get the value which is growing at a certain rate and then you discount it, so increased value we will be able to find out. So, we will have to adjust here for the growth factor. So, there is some difference in the simple annuity and the growing annuity, and the growing annuity has to be say adjusted for the growth rate, and after that it has to be discounted. So, it means if you want to find out the discounted value of the growing annuity, that will be certainly more than the discounted value of the simple annuity or the constant annuity, right. Now, how you can calculate the say for example, this is application of the say present value of a growing annuity. This is one important example, or the application of the present value of the annuity. For example, suppose you have the right to harvest a teak plantation for the next 20 years in one field of the teak. We have purchased that field and teak trees are planted there, which we can harvest plantation for the next 20 years, means for the next 20 years, every year for example we are harvesting that, or every 2 years we are harvesting that. For next 20 years that rights have been purchased to harvest that teak plantation, and over next 20 years, over which you expect to get 100,000 cubic feet of the teak per year, 100,000 cubic feet of the teak per year. The current price per cubic feet, the current price per cubic foot of the teak is rupees 500. The current price per cubic foot of the teak is 500. What it is expected to increase at the rate of 8%, right. What it is expected to increase at the rate of 5%. Per current price is how much? Current price per cubic feet of the teak is 500 rupees, but it is expected to grow at the rate of 5%. The discount rate is 15% and the say the present value, if you want to calculate of this annuity, which is a growing annuity, means here what is happening, number of years for which we can harvest the this plantation of the teak wood is for 20 years, right, and we are going to get the say total per year output in that field is going to be 100,000 cubic feet. But the price per say cubic feet is going to be, you are going to sell that say teak wood in the market for 500 rupees per say cubic feet, but that price of 500 rupees is not static, it is not constant, it is going to increase over a period of time, and increase in the price for the say per cubic feet of the teak is the growth rate is 8%, and discount rate for calculating the present value of this say annuity, growing annuity is 15%. So, with the help of this model, you are what you are doing here is you are giving the power of 20 years and then you are finally adjusting it against the growth rate, and growth rate is going to be, so here this is 1 minus 1 plus g power 20, and in the denominator also we are adjusting the discount rate with the growth rate. So, finally you can call it as the discount factor has come down to 7% rather than 15%, and when this because of the growth of the selling price of the per cubic feet of the teak, final value which we are calculating here, which we will be getting here for this total investment proposal, which the rights we have got for harvesting the teak plantation for the next 20 years is going to be 550 millions 736 and 683 rupees. So, roughly you can call it as 500 and say 51 millions and 7 lakhs, almost you can call it as 700,000, you call it as 551 million and 700,000 worth of the teak is going to be harvested over a period of next 20 years period of time, because the selling price is not going to remain the same per cubic feet of the teak plantation, the price is not going to remain the same, it is going to increase. So, what we have done is we have multiplied the price per cubic feet and multiplied by the number of the cubic feet going to grow and going to be available with us, and then it is multiplied 500 by 100,000 and the growth rate is 8%. So, this value of the growing annuity we have calculated first, then factored with the certain other values and the growth rate. Finally, we are going to find out that the total crop is going to be worth 551, more than 551 million rupees, which is the result of the growing annuity, because selling price is not constant, selling price is going up at the rate of 8% per annum, right. So, this is the growing annuity. So, there is a difference between the say static annuity and the say growing annuity. So, if any annuity is going to grow, this inflow, cash inflow which is coming over the period of say subsequent future years is not going to remain the constant, but is going to increase and is going to get affected by the growth rate, then you can understand that how to calculate the value of that growing annuity. With the help of this model we can easily find out and we can easily calculate. Now, I was talking to you about something that is the annuity due, ordinary annuity and the annuity due. We should be very clear about it, because in the beginning, if you remember, I started the process of I started the process of time value of money, I say discussed with you a timeline, right. If you go back, it was a timeline which we discussed, and in this timeline we can go back in that timeline. In the beginning we started that something about the cash flows. Cash flows coming in the beginning of the period or cash flows coming at the end of the period. This is the timeline I talked to you about. In this case, the basic difference here is that in the one say structure, the part A, if you talk about, cash flow is occurring at the end of the period, at the end of the year, means at the point 1, not at the point 0, and in this case the cash inflow, cash outflow is also occurring at the point 0, cash inflow is also occurring at the point 0. So, these are the two different kind of the annuities, right. So, this is I am going to talk about the timelines here in terms of the annuity due. So, if you talk about what is the difference between the ordinary annuity and the annuity due, so we can understand with the help of this timeline again. Ordinary annuity is the one where cash flows occur at the end of the period, at the end of the annuity period, or normally 1 year. We also means normally assume it that whenever any investment is made, that investment is made in the 0 period. This is the 0 period. During this period we make the investment, and this is a period of cash outflows, not of the inflows, right. So, when any investment is made in the market, it is made in the 0 period, it works in the market, it operates in the market for a period of next 1 year, 12 months, and then at the end of the 1 year we get something back in the form of the cash inflows. So, normally ordinary annuity, we assume that the cash inflow will come at the end of the year, but in this case, in the annuity due, this annuity due is that both the cash inflow and outflow are occurring at the beginning of the year. Both these cash inflows and outflows are occurring at the beginning of the year, which is called as the annuity due. Here 0 period cash outflow is going, and in the same period the cash inflow is coming. For example, I told you in some previous class also that somebody say purchased a building for 10 lakh rupees, right, and immediately after purchasing that building for say 1 million rupees, he rented out that building or he leased out that building to some company or some organization, right. Company or any maybe financial institution. Companies or financial institutions do not prefer to construct their own building, rather they say believe in doing the business in the rented buildings. So, somebody purchased that building for 1 million rupees in the year maybe 2019, and in the beginning of the 2019, in the same year he rented out that building, and the lease agreement says that first year's rent will be paid at the time in the beginning of the year when the building will be leased out, that the lease rental for that building by the user of that building will be paid to the owner in the beginning of every year, and first year's rent will be paid right at that time when the building is leased out. So, it is coming in the beginning of the say beginning of any arrangement, right. So, this is coming in the beginning of the year. When it is annuity is the cash flow is occurring at the beginning of the year, it is called as the annuity due. Otherwise, the normal annuity which we expect is the cash flows occurring, which we assume that in the 0 period, in the current period, the cash outflow will occur, and over the subsequent years the cash inflow will occur, and when the cash inflow will occur, that will normally occur at the end of the year, not in the beginning of the year, right. So, the basic difference in the two is that annuity due value, if you want to calculate the sum total value of the annuity due, it will be something more than the ordinary annuity, because you are going to pay this amount is going to come to us here, not at this level. So, the interest for this period you have to calculate, interest for this period you have to calculate. So, annuity due is ordinary annuity multiplied by 1 plus r. So, 1 plus r is a period for this interest. Under ordinary annuity, your inflow is coming at this point, but under the annuity due your inflow is coming in the beginning. So, rather than coming at this, it is coming at this point. So, the interest for this period has to be calculated, which has to be multiplied, used for multiplying the ordinary annuity. So, that amount will become the annuity due. So, be careful always about the point of cash flow and the period of cash flow. These are two important things. Time and again I am discussing this point, time of cash flow and the period of cash flow. If in the beginning, then it is the annuity due, but if it is at the end, then it is the ordinary annuity. Now, there is another thing which we call it as perpetuity. It is not annuity now, it is called as perpetuity. Perpetuity means something related to the perpetual, something of the nature of the perpetual existence, uninterrupted existence. Perpetual means uninterrupted existence. So, if it may be possible that sometime when we purchase any investment and the benefit of that is going to be there for say unlimited period of time, infinite period of time, unending period of time, that investment is called as the say perpetuity or the perpetual investment. Now, what is the meaning of it? A perpetuity is an annuity of an infinite duration. A perpetuity is an annuity of an infinite duration. So, infinity is involved here, means when any duration which is not countable, means on fingers or otherwise, or which is not foreseeable, which is infinite duration. Once you have got the right over any particular asset, that is going to remain there forever, unlimited number of years, for the infinity number of years, then that investment is called as the perpetuity, and the present value of that perpetuity can be worked out. The present value of that perpetuity can be worked out with the help of this formula, that A by R. A is the cash inflow, A is the cash inflow which we are going to find out, and the R is the discount rate. And otherwise also you can easily find out that, for example, A is the 10,000 rupees and R is the say 10%, that discount rate is 10%. If you try to find out, this amount becomes how much? This amount becomes 100,000 rupees, 1 lakh rupees, right. It means the any perpetuity which is giving us the constant cash flow or the return of 10,000 rupees at the end of every year, and the discount rate for that is 10%, it means the value of that perpetuity is 1 lakh rupees. Otherwise also, for example, if the value of 1 lakh rupees remains 1 lakh, it does not go down over a period of time, right. It is not impaired because of the period of time or because of inflation factor or because of any other factor which causes a reduction in the value of the money. So, you invest that 1 lakh rupees anywhere in any investment, and annual rate of interest on that is going to be 10%. Certainly, how much is we are going to get the annual cash flow? 10,000 rupees. So, this is called as the perpetuity, present value of perpetuity, or the perpetual investment, where the return comes back or the cash flow occurs for the infinite number of years, unlimited number of years. It can happen, and we can use this also in many business decisions. Now, we will talk about some other interesting concepts. Shorter compounding period, shorter compounding period, and this is very practical concept these days. Till now we were talking about the compounding concept. We have talked about the discounting and compounding concept. So, till now we were talking about that is the, say we discussed the concept of the future value of the annuity. So, when we are talking about the future value of annuity, it means we were talking about the compound interest there also, but there till now the compounding, the period of compounding was considered as 1 year. Period of compounding was considered as 1 year, that annually the interest has to be compounded, right. So, for example, we are investing 1,000 rupees at the rate of 10% rupees. So, at the end of the year it will be compounded once in a year. So, at the end of the year the amount will become how much? 1,000 plus 100 is 1,100, 1,100 rupees. In between we are not compounding it, but if you are compounding it for a period of more than a year, or rather than going for annual compounding, if you are compounding it for the multiple periods within a year, sub periods within a year, then how to go for it. This is a concept of the shorter compounding periods. So, in the shorter compounding periods, what you can do is you can take here, means you have to make some minor change in the say future value formula for calculating the compounded value. In this future value formula, what we are doing it, present value, and that is 1 plus R divided by M, and M is what? M is basically the number of times compounding is done in a year, right. So, what is given in this model? If you look at this model, so in this model you are given certain things, and what these things are? R is the nominal annual interest rate, and if for example, if compounding is annually, then we will not divide it by M, right, it will remain R only. But M is number of times compounding is done in a year. These days I told you the compounding is done say you can call it as twice a year, 6 monthly compounding, quarterly compounding, monthly compounding, and these days nowadays if you talk about the banking system in India, then there is a daily compounding. But on the borrowing also, if we are borrowing anything from the bank, they are compounding it on the daily basis. If we are investing or depositing anything in the bank, we are also getting the interest on the daily basis, but daily compound interest. It is not a simple interest, it is a compound interest. So, here R is the nominal annual interest rate, M is the number of times compounding is done in a year, N is the number of years over which compounding is done, N is the number of year for which the compounding is done. So, if the compounding has not to be done once in a year, but it has to be done for more than times, more than one time in a year, then whatever that interest rate we are going to get back annually, that has to be divided by the number of the compounding number of the times of compounding, number of the times of compounding. So, for example, we have this information here, say 5,000 rupees we want to invest, right. Rate of interest, annual rate of interest is 12%, and the compounding rate is times of the compounding is 4 times a year, and total number of years for which this amount will be invested is 6 years, right. So, you can with the help of this particular model, you can find out that what is going to be the compound value or the compounded value of the 5,000 rupees invested for a period of 6 years at the rate of 12% of the interest, where the compounding is done 4 times a year. This amount becomes more than double of the 5,000s, and this amount works out as 10,164. 10,164. So, this is the magic of compounding. This is the, say, you can call it as the power of compounding, I would say. And when number of times when the compounding increases, when there is annual compounding, the return will not be very high, but if it is the quarterly compounding, it will be more. And nowadays this is a daily compounding. You can understand how much difference it makes, whether it is the borrowing from the banks or it is the depositing in the banks. But the sorry part of it is that whatever the interest we earn from the investment in the bank deposits, that is subject to the tax. So, in this entire case, means we can answer a question that if the compounding periods are more than 1 in a year, then how to try to find out the value of that investment given the rate of interest, annual rate of interest, number of compounding times and the number of years for which the investment can be made. One more important corollary of the time value of money is the effective versus nominal rate of interest. Effective versus nominal rate of interest. Now, what happens that when we go to the bank or any financial institution, we ask them that I want to deposit my say sum, maybe 1 lakh rupees, 2 lakh rupees for a period of 3 years or for a period of 6 years, for a period of 5 years or for a period of 1 year. How much interest will I get? Then bank talks in terms of the simple rate of interest or the nominal rate of interest, that they say that yes, for the fixed deposit of 3 years we pay 6.25% rate of interest per annum, right. So, that is called as a nominal rate of interest. But you see, as I told you that interest will not be a simple interest when it will be calculated, it will be the compound interest, it will be the compound interest. So, on the simple interest daily compounding will be done and on that deposit, and when you do the daily compounding, so what happens? The effective rate of interest becomes certainly more than the nominal rate of interest. Effective rate of interest certainly becomes more than the nominal rate of interest. So, many a times you must have heard about that many private companies or even banks, when they advertise for seeking the deposits from the public, they say that rate of interest is this, but the effective yield is this. So, yield on the investment is this. So, yield I am talking about is the compound rate of interest. What is the rate of interest they are say they are advertising for is simple rate of interest, nominal rate of interest. But practically when it comes back to us, provided we do not take the interest back every period, every year or every month or every 6 months, we do not take the interest back. If we allow the company to reinvest the back also, so that interest is known as the effective rate of interest, and that is different from the or more than the nominal rate of interest. So, in this case you can calculate with the help of this model, the effective rate of interest can be calculated with the help of this model, and here you can say that effective rate of interest is R is equal to 1 plus k divided by m, that m is number of compounding periods and power m minus 1. R is the effective rate of interest, k is the nominal rate of interest, right, and m is the frequency of compounding per year. And in these days banks there is a daily compounding. So, this is a compounding and on the daily basis the say deposits are compound, loans are also compounded on the daily basis. So, finally, in this case for example, a simple rate of interest for example in this case is 8% and m is 4 times a year, compounding will be done 4 times a year. So, R in this case becomes how much? This becomes as 8.24%. This is called as EFR, effective rate of interest, ERI. This is the effective rate of interest, ERI, as compared to nominal rate of interest. The nominal rate of interest is 8%, but the effective rate of interest is more than that, that is by 0.24% it is more. So, it becomes 8.24%. So, always be careful when you make the investment in the any financial institution or in any bank, always ask for that yes, this is the nominal rate of interest, but what is the say effective yield available from this investment, right, and that will be known as the compound say output available. So, here is a chart which has been calculated again in the same book by the Prasanna Chandra. I have taken this directly from that book. So, nominal and effective rate of interest are given here as some chart is given. For example, nominal rate of interest is 8% or to 12%, annual compounding is done once. So, it will become 8 and 12 means no compounding, almost you can say annual compounding. So, at the end of the year you will find it out 8% and 12%, but if it is semi annual compounding means every 6 months if it is compound, then it is 8.16 or 12.36, quarterly compounding 8.24%, 12.55%, and monthly compounding if it is done. So, actually it works out as 8.30 and 12.68%. So, you can understand the magic of compounding. You can understand the power of compounding here. The moment the number of compounding periods increase or times of compounding increase, the effective rate of interest is going to increase at the same speed or the same pace. So, it means in this case when we talk about here is effective earnings, that effective annual rates and the you call it as the simple say applied rate of interest, this EAR and the APRs. So, in this case you can find out is the say effective annual rate and the annual percentage rate, APR and EAR. If you want to find out, there is a basic difference, and we should be very, as a student of finance, we should be very clear about this difference, that effective annual rate is the one that reflects the total amount of interest that will be earned at the end of the year, total interest which will be earned at the end of the year. In this case we have found out is that we will not be earning 8.28%, but on this investment if the compounding is done 4 times a year, we will be earning 8.24%, right. So, in this case the amount of interest that will be earned at the end of the year. It is also referred to as the effective annual yield. I told you that effective annual yield or the annual percentage yield, which is called as APY, annual percentage yield. So, there is a difference in the interest and the yield. There is a difference in the interest and the yield. When you talk about interest, you talk about the nominal interest, but when you talk about the yield, you talk about the compound interest. So, if we are not taking the interest back over the periodical intervals, we are allowing this investment to be given once, we will be taking it back at the end of that investment period along with the principal and interest. In that case, the interest which we will be earning will be the different one, and that will be called as the effective annual rate and not the simply the annual percentage rate. So, annual percentage rate is the amount of simple interest earned without considering the effect of intra-year compounding. This is the simple rate of interest earned without considering the effect of intra-year compounding. So, this is the basic difference in the two. One is the compound interest and second one is the simple interest. So, when we go for any investment avenue and try to find out what is the interest rate they are offering, whether it is a bank deposits, whether it is any bonds of the companies or any other investment avenue, always be clear about that if they are talking about rate of interest or they are talking about the yield. If the rate of interest they are talking about, so whatever the rate of interest they are offering, always be sure that the total effective rate of interest annual yield will be certainly more than that and not the one which is they are talking about. They are simply at the moment they are talking about the simple interest, and the actual output or the actual yield which will be called as the effective annual rate EAR, that will be certainly more than that. So, you can compare your investment in the one avenue with the other avenue in terms of the yield available and not in terms of the nominal or the simple interest available. So, with this, these are some of the, you can call it as the important applications of the time value of money, where we could discuss the different concepts, and my objective here was to make you clear about with the basic techniques of the compounding and discounting. Compounding and discounting, because time value of money is very simple to understand that a rupee in hand today is not equal to a rupee which will be earned or will be coming back to us after a period of 1 year. Rupee earned after 1 year is not equal to the rupee in hand today, right. So, there is a difference in the two values of the money, because one is going to come back to you after 1 year and currently 1 rupee is available. So, you can compare it, say people say that award in hand is better than 2 in bush. Same is the principle applied here. So, if you say that you want to take, say somebody offers you that do you want to take say 200 rupees today or 300 rupees after 1 year, right. So, you can easily understand that 300 rupees coming to me after 1 year or 200 rupees I am getting at the say present moment, I think it is better option to get the money what is available, that is 200 rupees, say presently is equal to 200 rupees, but 300 rupees coming back to me after 1 year is not certainly 300 rupees, but less than that. So, there plays the role, means there comes the role of the compounding and discounting. So, when you talk about the, if you want to calculate the future value of the present amount, you apply the concept of compounding, and if you want to find out the present value of the future amount, you apply the say the concept of, or you make use of the concept of the discounting. So, after compounding and discounting, the final value of the cash flows which occur to us and occur out of us is different, and we should be clear about that. What is that amount, how to calculate that amount, and how to make use of this concept of the time value of money in the real business decisions. So, with this concept of time value of money, I will stop here. I think I could discuss some of the important concepts, and again I would emphasize upon this all discussion which I could do here is I have referred to the book, that is Financial Management by Prasanna Chandra. If you have any doubts or you want further more information, more problems to be solved about, or you want to have some clarification about the discussion I am doing here, which some part may not be clear to you, though you can ask in the say question forum later on when the course will be run. But if you want to have for the detailed discussion or learning about what is the time value of money and how to do it, you can again refer to the same book Prasanna Chandra, which is a very useful book, and you can make use of it for the detailed and the say you can call it as the very clear say the learning of the financial concepts without any kind of the doubt. So, for this time value of money and to learn about this entire concept as a whole, whatever possible was I could discuss with you. So, I will stop here for this class, and next time we will move with the next concept of the next important concept of the financial management, which will be of a certainly very good use to the say corporates in their practical life for managing their finances well. So, this is all for today, that is all. Thank you very much.